All right, hello. I think we're back. The stream looks good. The bitrate looks good. CPU looks good. No dropped frames. So yeah, welcome to the stream today. Sorry about the scuff before. I don't know, something weird was going on with my computer before. Probably because I had used a capture card before, which acted up and stuff. I don't know. Stuff was strange. All right. Sound okay, good. So I have a fan on, and I really hope that you can't hear it, but it's needed. It's 30 degrees Celsius here, which is really hot for Sweden. Maybe not for other places, but yeah, here it's insane. Let's see here. All right. I don't hear it. Okay, wait a second. Why not? It should work. Yeah, I can hear it if I listen to my stream. So that's weird. Maybe if you refresh, because usually you don't hear the fan. Oh, sorry. Okay, good, perfect. Okay, so maybe we should start with the recap. So going back to August 27. Let me just move around some stuff here on my other screen. Yeah, so August last year, I was poking around with the Nintendo 64 as well. But at that time, I was using a Glasgow. It's a piece of hardware which contains an FPGA and a USB high-speed interface. And I implemented a video and audio capture solution using the Glasgow together with the N64. And this video was that stream when I had gotten everything to work. And as you can see, it's super sharp, it's crisp. All the softness that you see here, it's upscaling from, I believe, OBS. So I can just explain really quickly what is going on here. So essentially, this is the reality coprocessor, so the chip that outputs the digital video signal, and then the DAC converts these digital signals into composite and luma and chroma. Yeah, I don't really know what video is, if it's composite or if it becomes composite later on, but that doesn't matter. What matters is that we have these 7 bits of data and a special sync signal and a clock as well. So yeah, what I did was to connect. So I have modded my N64 and soldered wires to these pads. So yeah, you can't really see it here, but it's more or less in a row of the reality coprocessor. So it's not like spread all over the place. And these wires I had connected to the Glasgow, and then in the Glasgow I had written gateware that implements this protocol scheme, whatever you want to call it, streaming scheme, I suppose. It's basically RGB plus sync signals in a separate channel. So it's like when this desync is low or something. I don't really remember the details because it's 1 year ago. But anyway, yeah, you have 4 bytes per something. Yeah, I have forgotten everything, to be honest. I have the code still. Oh, you redeemed hydrate. Thank you. I will hydrate. Thank you. So yeah, so anyway, I don't remember the details, so I can dig up the code again so we can have a look at it, because it works. And the fun thing was that I also wrote code to to grab that frame buffer and audio together, put that into the user space, Python application layer, and convert that into a FFmpeg video stream that was then fed into what is called again? Video for Linux, which created like a virtual webcam. And using OBS, I could then use that webcam and use it in OBS. So if you probably recognize this. It looks just like my stream normally does, and this is just a webcam just like anything else. So I just wanted to show you that because it's kind of ties into what we're gonna do today. And it worked really well. The latency was really good, and I didn't have any dropped frames, and it was actually way better than expected. I didn't really think it was gonna work that well. So today, when I was out biking and my brain started working on its own in the background, I just thought, why don't I do this again, but with a Raspberry Pi Pico? That would be pretty cool. So yeah, that's what we're gonna do today. So where do we start? So we can start by just looking at the pinout. Yeah, we have these 7 pins plus this special sync pin. We have this clock pin. I will probably need to dig up a photo of the pinout, because right now I have a rainbow cable that just sticks out of the N64, and I don't really want to unscrew everything. So let me just dig around a little bit. So sorry for the delay, I guess, because I haven't connected anything yet. I wanted to do that before the stream, but stuff happened, so I didn't really have it wasn't possible. So I guess we can I'm just gonna search for August last year and try to more or less find a photo of the pinout, because I'm and here it is. So I'm just gonna save this. Second. And then we can do like this. Okay, so we start from Ren's PicoDVI example, probably. Yeah, that's a good, I was thinking that as well. So what we're looking at here is my rainbow cable, which is soldered to the video DAC directly. And I have a PAL unit, so this is slightly different on the NTSC versions. But yeah, this picture is important to me because I will use these pinouts to connect to the Raspberry Pi Pico to understand which pin is which. So I believe, I don't really remember which is which, but we'll figure that out. So I think one is ground and one is voltage. I think that is probably ground and that is probably voltage, and that is perhaps the sync, because it's going somewhere else as well. The other ones are 1, 2, 3, 4, 5, 6, 7. Yeah, the question is what this is. I'm not really sure. So anyway, that's my reference picture. I'm gonna need that later. So that's good to have. Not the best image for you. But anyway, I have that. So there are many things we want to cover today, and I have to work tomorrow. But so I will have to end the stream at like midnight. So we have 5.5 hours. So how do we want to spend that time? We could, I don't know. Question is like, how fast do we want to run? Like we could like get the HD or I mean DVI-D stuff up and running quickly and test that and try to interface with it, which is really cool. Or we could start with grabbing the video signal and turning that into data, more or less. And I think the latter is probably the thing that makes most sense, because as you can see here, there's a clock which is 50 megahertz, and the Pico runs at 133. Or I mean, we can change the clock of course, but in contrast to a FPGA, because in the Glasgow solution there I used this clock signal as a actual clock signal, so I was latching the data on the rising edge of the clock, if I don't misremember. I suggest PicoDVI first. Okay. I mean, we can do that. So I have the board soldered up, and I will, yeah, let's just build it and see how it works. PicoDVI, I believe. So I guess we go to software. Yeah. So it makes more sense to video out would be immediate feedback, and project depends on viability of video output. That's also true. Because yeah, if you just think about it as a system, we have the Raspberry Pi Pico is limited in various ways. We only have full speed USB, which means up to theoretically 12 megabits per second, which is not enough for video. We have what more? Yeah, I don't know what I was thinking. There is not a lot of like fast outputs that are not like raw I/O. So the DVI out is a very cool and good way to send data, send lots of data. So it makes sense for sure. So let me just connect a few things here. So I do have a HDMI capture card, and OBS might blow up when I connect it. It kind of did that last time, so a little bit worried about that. But we can try anyway. So we can start with just flashing the image using, I guess, SWD. Yeah. I'm just gonna connect the debug the J-link to the target. So I'm just wiring some. I can start the camera so you don't have to look at the boring terminal. Let's do this. So yeah, there's my desk again. So ground. And also like the silk screen of the debug header. It's a little bit, oh, the focus is completely whack. Yeah, I don't know. Video in Linux for me has been a complete pain. So now I guess no camera then. So anyway, I'm connecting stuff. What do we have here? Just VREF. So yeah, my plan was to have everything connected when the stream started, but I'm sorry, I didn't manage. If I wasn't so dependent on graphics and video, I'd rarely drive Linux, but that's a conversation for another day. That's I agree. That stuff just tends to just work on other systems. Okay, so I always mix up the order of the pins here. Link. So yeah, I was saying the silk screen of the Raspberry Pi Pico debug port has like a triangle on the clock, SV clock, which is kind of neat because it resembles like a how you draw a flip-flop, like so. Of course, it doesn't look like. Yeah, here you see this little triangle. So it's kind of neat. I like it. I have the reset pin. Instead of feature creep, it's project creep. Yeah, I mean, the thing is, right now I just feel like exploring stuff, and there's so many things I want to try. So yeah, I just want to explore. And this is, this is just really, nobody knows how this is gonna go. I'm fairly sure that we should be able to grab video data and like print it over USB UART or CDC and recreate like a small piece of the frame buffer in the PC. I believe we can get there. But getting like real-time streaming DVI-D data, let's see how far we can get. Okay, so unfortunately, okay, like 5 meters of 50-50 lead strip. Yeah, I mean, you're right. I need better lighting, but I also need better everything. Like, hello, where is the camera? I'm gonna unplug the camera and plug it back in. Maybe it will start working. Who knows? Switch to USB port. The camera works outside of OBS. Let's see if it works in OBS. Sorry, I'm just gonna go to studio mode. Okay, so it seems to work. Okay, so finally it works. Don't worry about stream quality for now, just good to see you working. Set up a patron native sponsors. Yeah, I might actually do that. So actually, during my Game & Watch stuff, I managed to get like enough viewers to enable the affiliate stuff. So technically, I mean, you can subscribe and stuff here in order to sponsor the whole random projects. I don't have any any promises or any it's just sponsorship without any any promises. It's just, you know, if you want to do it, you can do it, and it's greatly appreciated. But yeah, I just enabled it more or less for fun because it was possible. So anyway, I do all of these projects just for fun and because I want to do them. So yeah, and I don't feel any pressure, and I just do whatever I want to do. So anyway, let's get back to where we were. So I've now connected this Raspberry Pi Pico to my debugger. So now can do this one, I guess. All right, it's not much to see on the camera right now, so let's just go full screen. So let's there. Okay. So let's look what we have. We have a lot of cool stuff. I think Hello DVI is like the best thing. I had a quick look at this code before, and it looks like we're just we have like a test image, and we're basically scrolling it. So very simple code, which is very good. So it's easy to understand. And I believe this is all built instead of apps, right? We have the Hello DVI, and we have the elf file, right? So we just use our old OpenOCD command, like we used previously, and right, we need the full path. So let's do like this. And this is multi-core stuff, so this time we will remember to disconnect power and reconnect it. Yep, so now it's running. So let me just connect this to a third screen. One second. I've connected it, so I'm gonna look at the screen. And it's actually black. It's actually black. Okay, so it doesn't seem to work directly. It could be the cable. Let me try a different cable. What is the goal of the stream? DVI output from N64? Yeah, actually, yes. Yes, that is the sort of end goal. And in order to get there, we need to cross a couple of hurdles. We need to first be able to capture the video data, and then we also need to output the video data as DVI-D. So currently we're trying to get the Hello DVI project to work using Raspberry Pi Pico with the HDMI mod, or yeah, there's a HDMI connector on it. But currently it doesn't seem to work straight out of the box. So just gonna fetch a different HDMI cable, because that could be the issue. So the screen I'm using is a Dell PC screen, which I have been using to show really strange DVI signals. I've experimented with my FPGA on that screen with like weird resolutions and weird sync timings, like 53 hertz and whatnot. So that the screen should really be, you know, not the problem in this case. Oh, okay, it was the cable. It worked immediately. So let me show you, I guess. I kind of don't dare to move this camera around too much. Yeah, it's, I don't know. It's kind of hard to show it. But yeah, let's just say that it works. I can see it on my screen. That works fine. And yeah, I'm tempted to try using the capture card, to be honest, because that would be really cool if that worked. Because then we could, oh, sorry. Then we can use the capture card to show whatever the Pico is showing on stream. So I'm just gonna need a little bit of longer cable. Yeah, I have a lot of USB cables, but never the right one when you need it. All right, I'm thinking the wrong way. So I thought I needed a long cable from the screen to the capture card, but it's actually from the Pico to the capture card. So, and that is close. So just 1 second. And also sorry for all the scuff, but this is like a developer stream, so there will be a lot of scuff. It's just how it is. Because we're doing kind of not the standard stuff. Okay, so I connected the capture card, so let's see if OBS explodes. 1 second. Okay, so Camlink input shows just a black input. Which is kind of unfortunate. Yeah, it doesn't seem to be able to decode the signal. It detects some stuff, like I get like a strange resolution, like 714 by 345. Yeah, that looks really off. Longer cables too long. No, so the cable I got was a really thick one and short, so it's like super isolated. I think it can do 4K and so on, and it's like 1.5 meter at most. Yeah. So I guess the capture card route didn't work. Let me just try if I can get it to work in a different viewer. So I'm just gonna disconnect the cam link, plug it back in soon. But yeah, this stuff is always a bit okay, so I just get a black screen, and like the camera is supposed to be working, but it's just completely black. Without HDMI tester, it's hard to discern actual quality of the cable. Thickness means nothing. True. I mean, I have, I guess, 5 more cables we could try, but yeah, that's gonna be really boring. But I tried with 2 different cables, and they are quite different. Like, one is thin, and this one is like really thick. And it worked with a Dell screen, so yeah, I guess I could do. Okay, I'm gonna try to do one thing. I'm gonna set up the screen so that I can show it. Okay, so bear with me a little bit. Okay, this might actually work. Okay, I found a solution. Just need some tape. Just give me a second. And we have no dedicated file with proper amplifiers and termination here. It's all really fragile. Yeah. Yeah, oh, that's true. But I unfortunately don't have that here. Unfortunately. I actually implemented my own HDMI capture card using an FPGA and just reading the input. So this is extreme. This is gonna be like extremely scuffed, but it actually seems to work. So let me just connect everything up together. And just like before, the focus is horrible, but behold, my webcam capturing my 27-inch Dell screen, which is behind my other screens. But yeah, it is something. It is not perfect, but there you go. I'm sorry for the horrible stuff, like it looks like crap, but at least you get a small glimpse of how it looks in reality. So I think, yeah, this will do. So I guess this will be kind of distracting in the long run, so maybe we should kill it soon. But anyway, we've shown that it actually boots and the output works, and my Dell screen can show it. I was going to suggest the same thing. Okay, cool. So I'm just going to look at the settings. Hey, we can see something. Yeah, exactly. Like looking at like a console or a code that just doesn't change. I totally understand that that is boring. So. Okay, it says 640 by 480 and 60 hertz. So it's actually correct. Nice. And the capture card was all completely wonky. It said like 740 by 3 something. I don't know. I didn't understand really why we got that value. Okay, so where do we go from now? Do you want to understand what we are doing here? Like, yeah, you can see the code as well. Yeah, I'm just gonna make the terminal the same size, make like a mock terminal so that we're on the same page. Yeah, cool. So now build Pico Infinite and let the rest of the stream be Super Mario. Yeah, I mean, I wanted to check it out. So let's go there. Okay. Okay, something is wrong. Do we need submodules? Yes. Okay. Ah, now I see. So I was wondering what the little thing was on the yeah, on the video, but it's the arm from my screen rig. Okay, okay. Okay, so it's been flashed. I'm power cycling. I have no idea what's gonna show up here, so let's hope it's not anything weird. Okay, I power cycled. It did not work on the first try. Maybe it's using different IOs. Should we read the code and try to understand what's going on? I mean, it's using PicoDVI, right? But let's flash it one more time. And power cycle again. So the screen doesn't light up. So I'm just guessing that it's using different IOs. So I'm just trying to figure out where the IO stuff is being set up. Maybe the default pinout of the HDMI column. Okay, so I have the DVI sock, so that should. This shouldn't be needed with my screen because, yeah, we just ran the other example. Right. We need to load a ROM. So, yeah, just 1 second. I'm gonna find a good ROM. Let's go to here and go to our CI and use the open source. Oh, not there. Already forgot it. How this project is set up. Here we go. This one. So how big is that? That's only 257 kilobytes. So that should be fine. So now we need to program that to this address. So now we're writing the ROM as well. And power cycle time. Hey, something happens. Oh, it boots. Damn, this is really cool. Holy crap. This is really cool. Okay. Yeah, this is cool. You can use a DualShock? What the heck? How? Well, how do you wire it up? What? I mean, I'm reading the README, but I don't. What am I missing? How do you actually connect the controller over USB? So how do you do that? Like, do I have an OTG adapter? Yeah, I know that I have one. Let me see if I can find it. Yep, found it. I have this. And I do have a DualShock 4, so let me just connect it. So I guess, but how do we power the board when it's connected? Ooh. By the way, there's regarding exotic Pico derived boards with Wi-Fi and stuff like Pimron. Okay. Yeah. I'm not really sure how this is gonna work. Or maybe, okay. This is, yeah, let's see if this works. So I'm gonna plug the OTG adapter into the Pico. And then I'm gonna use a small USB cable to connect the controller. And then power the board. Also the USB. Does it boot? No. It could be that the OTG adapter is jank. Yeah. Wait a minute. So I'm gonna power the board with 5 volts instead. Okay, it lights up. Something is happening. Okay. Ha! It actually it actually works. This is really cool. It's a little bit hard to show you. Yeah, the OTG was being weird with external voltage, but now I'm powering it with the V-bus pin instead. And yeah, it works. If I can figure out which button to press. Yeah, can't press down, it seems. But okay, but almost. Now something happened. I reset it. Yeah, okay. It seems the start. I'm not really sure what the start button is. Okay, that is. Okay, here we go. Okay. Yeah, so it definitely works. It definitely works. That is really cool. This is running on a Pico. That's crazy. Wow. Yeah, so I guess that means that this is a really cool demo. So now we know my screen works, the HDMI or DVI stuff works. So we can. Is that the game we want to check out? Cool. Nice. Yeah. All right. So I guess we should start coding. Otherwise, time will disappear. It goes so fast. So let me just disconnect the OTG stuff. Yes. So the question is now, what is the best way forward? So now we've verified that we have a test setup where we can, we can use the DVI stuff. So I guess now we should grab data in a way and present it. So what is the best way to do that? Yeah, PIO obviously, but then what? Like we could do it in many different ways. Like I'm trying to figure out. We should have like a scan line where we write, like we sync. Yeah, the timing will be difficult here because we have 2 asynchronous clock domains. If we just think about it, we have this 50 megahertz clock, and then we have our own system clock. Familiarize ourselves with internals of PicoDVI. Yeah, that we can do. That we can do. So just going back to this example. Yeah. So in this case, yeah, we're just offsetting this with the Y scroll here. So can make it go the other way around. Output format and presentation mostly. So if we just read what we're doing, we have a init function. Oh, this time it actually worked without me having to replug it. That's interesting. So I'm not really sure how these spin lock thingies, what those even are. Just want to get familiar with the queues. Haven't really seen these queues before. First, last. Okay. Pthread mutex. Okay. But I think I ended up some completely elsewhere. Why do I get there? So right, I need to include the Pico SDK. So just 1 second. I'm just gonna yeah, just 1 second. So I added the Pico SDK to the project. Yes. So now maybe we can find the actual implementation of the queue. Maybe this one. Okay. All right. Okay. Yes, this converts the pixels into TMDS encoded words, I suppose. Where did scan buff come from? That is just something. Aha, okay, okay. The color valid. So, oh, okay. You need particular modes. You need particular modes, resolution, color depth, and buff format. Yeah, that's true. I guess either it's 565 or... Yeah, I mean, I've implemented TMDS on an FPGA, so I'm aware what it is, but it's also nice to not care about it. We can just accept that, yes, it exists, and we don't have to... Oh, it is actually 565 here. Yeah. Okay, nice. So actually, if we just look at this, we have a little bit of a limited color space. It's only 7 bits. So it is actually RGB 777. And I think, I mean, we could do it kind of ugly and just do 565 and ignore, or I guess like 454, so that we ignore these 2 bits and this bit and these 2 bits, and it will be like goodish enough. Scan buff main is a helper that takes color buffers and streams them into TMDS buffers. Okay. Right. Oh yeah, okay. Okay, so now I see. So we have our buffer and we have our position. We take the pointer, we call this scan line, and we just put this pointer to this queue. And then we wait until something is added to the color free, and then we do it again. Okay, I get it. How are you planning to handle the sync between the N64 and DVI out? Will you be able to do it without a frame buffer? Yeah, so that is what I was thinking about. Like I was starting to talk about the different clock domains and so on. So here we have a 50 megahertz clock, completely external, and the DVI stuff has its own, and they are not in sync at all. Like the only... Thanks for the follow. So the common thing is that we have the same resolution, or not even that. We have the same frame rate, or not even that. Sorry, because my my unit is running at the PAL, which is 50 hertz. So yeah, this is gonna be not good. Because the RAM is limited, we only have 250, 264, but in practice it's like we have I mean, let's say we have a frame buffer of yeah, like this. This does fit in RAM, so that we can do. But if we have yeah, I guess to start with, you can just have a frame buffer with DVI out and stuff the N64 RGB into the frame buffer. Yeah, I think that is a good starting point. So some games run at 640 by 240, I think. And if we do this in... Yeah, that is too much. So we can't really... Oh, thanks for the Prime sub. It's really appreciated. Have a look at the Mandelbrot demo to see a single frame buffer. All right. Yep. Aha, right, the Mandelbrot. Okay, so here we do have a frame buffer. And okay, let's read it from main beginning. Okay, so this is to boost it to 1.2 volt, right? And then we set the overclocking. So, okay. Okay, so you do this. So just doing this, the rest of the system will like just the other core would just render this frame buffer at its own pace. Can you show your hardware setup? I've taped down the camera, And the hardware setup is just a bunch of cables and yeah. I mean, I can take a photo and show it. I think that is the easiest way, to be honest. So, but it's really nothing fancy. It's really nothing fancy. Let me just take a photo. And then we do the magic internet thingy. Yes. Yeah, there we go. So this is how it looks. All right. So, okay, so we allocate the frame buffer, we configure it to become a sprite. The sprite will take up all of the screen, and the sort of rendering engine will render it all the time. So this is this is a very decent starting point. We could definitely use this. So I guess we can just copy this because it's easier to just keep working in your repository. So let's call this N64 and call it N64, and then in the CMake list, oh, it just does it magically. Oh, that's cool. Sprite fill is just a fill routine. It's not registering it as a sprite or anything. Okay, I haven't read this code that much, like the whole sprites engine stuff and so on. That's okay. So what does that actually do? Okay, so you can paint it or something with a color. Oh, is it like masking the pixel values with this? If you run the demo, you'll see. Oh, yeah, of course. Oh, I already think I can imagine. Let's do like this. Oh. So I'm not good at CMake, bear with me. So we're including apps. Okay. So here we have to do like so. Okay, there we go. It fills the screen with a solid. Oh, nice. And then draws my boat over it. Okay. Sweet. Yeah, this looks cool, and it's a good starting point. And yeah, just to be sort of productive, let's just work in your tree. That just makes life simpler. And then we're just gonna skip this and do like the so okay, for video data. So so how do we actually do that? Yeah, so let me dig up my old code. Not that. So actually, I had some issues with the whole sync stuff. and ended up hard coding a bunch of stuff. Like you can see here, it's horrible. But like the whole front porch and stuff, the resolution ended up being something kind of weird. But I think, to be honest, we could actually like debug it on the screen, because debugging it with UART and so on, and like trying to print those pixel values and put them into GIMP and whatnot, convert, it might actually be more fun to just debug it on the screen. So I think let's just go for that. So we're gonna go to software, let's go, applet, N64, video. Right, oh, I even put comments. Thank you, past me. Wow. Okay, so I think, I mean, this is all there is to it. This stuff is all high level Python stuff that we don't have to care about, and essentially this is the data grabbing logic. So it's really not much to it. And here's just some synchronizer stuff and the clock stuff. So here I'm adding the clock, setting it to become 50 megahertz so that the what's it called again? Yeah, when you compile the gatewire, that it's constrained to that clock speed, frequency. And then here I set up the yeah, some local signals which I'm using for the flip-flop synchronizer. This I don't think we need to care about, because there is already the two flip-flop input stuff on the GPIOs, right? So we're latching, we have proper data. Okay, so let's read this comment. When desync, so desync is this extra pin. We have these seven data pins plus a sync pin. And then this is just honestly, I don't remember what this is. Yeah, this is not from the pads, it's just a variable, right? So, or a signal, yeah. So anyway, we have this signal, and when that is 0, then D0, D1, D2, D3 become these special values. And I had some trouble trying to use them. Maybe I was just not really using my brain enough, but I made it work by doing the following. So yeah, when hsync and vsync are 1, so when D1 and D3 are 1, then I guess that is like the start of the frame, more or less. Or if it's the end of it, I'm not really sure. And then when either goes low, all right, this is a synchronization byte. So I had some issue packetizing, or whatever you call it, framing the video data. So I ended up coming up with my own scheme, which maybe is strange and stupid. But since we only use 7 bits for the color values, we have the LSB free as sort of a side channel. So in this case, I used this side channel as when that is high, then we send sync data. So this way I was able to, through the same pipe, send RGB data and sync data, because using 8 bits per sort of byte makes sense. And then we got this this LSB for free. So maybe we might have to do something similar, I'm not sure, with the whole push and pull and input shift register and so on, that we are reading 7 bits and then we're sort of adding a null bit perhaps. Or I'm not sure if that is possible, but perhaps. And that way we could deliver the vsync and hsync to the upper layer. And yeah, that is the sort of framing. So then for the whole logic, what do we actually do? So we have a counter which is used to count to 4. We have so if you look at this, you have this desync. When it goes low, it sort of means that we're starting this thing, and then it goes up, and then there's a clock, 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 down. So it's like down, up, 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 down, up, up, up. So it's down, up, up, up. So that is how you know if it's RG or B or sync values. So every time the sync goes low, we have to reset the counter, and then it counts up. And if the counter, I guess I count a little bit backwards here, so this actually means, yeah, right, we count up to 3 and not beyond. Right. And then we check the sync values and also the clamp, which I was not really sure what it actually means. There's a signal called a sync signal called clamp, the CL here, and I remember I was confused about what it actually means. And then vsync, hsync, and then right, the csync was used for composite stuff, and I wasn't really sure how we should use that either. I think csync was some sort of XOR or a combination of the hsync and vsync in some way. So I believe, because I think I read somewhere that the composite video generator is using this signal as a sync signal. So you have the video data and just one sync signal. But here we actually have the resolution to have hsync and vsync. But clamp, it might be active area. I honestly don't remember. So here I actually check if it's hsync and vsync are active, and then also the clamp one. And if that is true, then we're writing the data with a 0. So like this. So 0 first, and then the bits. In MyGen and NMyGen, we start from left to right. So this is the LSB, just in case you get confused. So we are combining a 0 and then the data, and then we put that into the FIFO. And if vsync is not the previous vsync, so if vsync is toggled, then we send out once, just one word on the FIFO, with the LSB is 1, and then the various sync signals. And for some reason I also send the old hsync and old vsync, but yeah, I don't remember the details here. And that's basically all there is to it. So it is really simple. So in order to convert this to PIO, we need to sort of first of all, we could like oversample, the clock. Let's say the clock goes at 50 megahertz, and then how fast do we run actually? We could, because we're already overclocking quite a lot, right? So, wait a minute. Okay, so where does that come from? Here. Okay, so we're running at 252 megahertz. So just a quick, if we do this divided by 50, then we're basically oversampling at 5 times. So we should have a very, very good sort of, what do you call it? Whenever we sample, we shouldn't miss any bits, essentially. So as long as we keep state and we're like detecting the state change on the clock, that it goes from 0 to 1, which we can do using the stall function. What was it called again? weight or something. Anyway, let's look at that later. But yeah, using that we can sort of wait for the clock to go high, and then we just latch the data, and then we just push it through the FIFO, and then here we consume it and put it in the frame buffer. So I think this should be fairly straightforward. So now we need to create a new PIO, the second one. We have the two different ones. So I forgot how to do this, like how to set it up from the beginning. So I'm just gonna look at my, I guess, our old code, because I feel at home. So first of all, we need to make sure that we have the CMake list is correctly set up. I'm gonna close this. Okay, so we want the hardware PIO stuff here as well, I believe. And then we also need to build the PIO stuff for our PIO. Let's just call it N64, make it easy. N64.pio. And let's just copy this to have like a starting point. And then we can start thinking about wires. So let me just dig up some photo. Or actually, we need like the pinout of that chip. Video duck pinout. Which we have here, of course, right? Yeah, so pin 1 and pin 12, it's in these colors. Yes. So now I'm just gonna connect a bunch of wires again. And so 1 to 12, so it's this one. This is the one that I have. So here we can see that the G0 up to D6, they are just going in a straight line, perfect. And then we have the desync, we have ground, and then we have clock, and then ground again. So they really care about ground here for the clock. So that is nice. So yeah, I'm gonna connect some stuff. So I have the N64 here right by my side. Maybe I can actually it's a little bit hard to see on the camera, but see these wires here? They come from the chip, which is underneath here. So we're gonna connect these wires to the Pico. And blue one. Yeah, so this is pin 1. Or D0, I guess. Honestly, I think I'm gonna go with the an extra layer of the wires, because otherwise it's going to be really fragile. And these orange wires, they're really nice. They are quite thick and have a lot of like, they are not that janky. But the rainbow cable, that is kind of like, here it's one signal that it doesn't want to stick at all. For some reason, it's just, I believe the other side of the connector is kind of crappy for some reason. So I'm just gonna find a different jumper wire. These wires are really not good. It's gonna be, oh. No, this is not gonna fly. So the issue is that the female part of the wire is for some reason way too large. So the cables are just coming off way too easily. So I'm gonna have to put the Pico directly here. So that's gonna be a little bit annoying. Let's go. It's all connected. Well, PCB vice to fix the Pico, maybe ordinary model vice some cardboard to avoid shorting. To be honest, I'm okay with the risk. Don't do this at home, I guess. Okay, so it's all wired up. It's a bit hard to see. I guess I can take a high resolution photo. Doesn't really. There we go. So let me just show you what I've got here. Guess I can do like this. Yeah. There you go. So this is pin 1. You see the rainbow cable here. We skipped the extra ground, and the orange cable there is the VCC, so should be fine. So we skipped this one. Yeah, so I've confirmed the wiring. So it's connected in this order. So IO 0, so GPIO 0 is D0, and then this is 6, this is 7, and this is 8. So the clock is at 8. So yeah, now it's time to write some code. Now the fun part begins. Just before we start, I'm gonna connect a USB cable to the Pico because it's not connected yet, but we need to be able to, yeah, connect it and power on the stuff, toggle power and so on. Yeah, there we go. Okay, so now the coding begins. So I think we should just try to compile this new code and make sure that we can sort of link it. Maybe we should write something really simple, like yeah, let's not do that, and let's just do like sample the 8 first pins and push it. So very simple program. We just read the first 8 bits and we push it, and then from the C code we can like just get that data and show it on the screen, just like a very basic. We want to get basically some noisy crap. Fill buffer with a single color for starters. Sure. So like insert. Where is the frame buffer again? I guess we want to do something a bit funnier, yeah. It's really simple thing. We do And then in 565 we write some color. So I don't know 565 by heart, so I'm just gonna do like this. It should be a darkish some sort of color, I suppose. Okay, so this should obviously be the width. Was this the right data type? Yeah. Okay, so I'm doing something wrong. We should get a gradient from left to right. Okay. Maybe it's just my brain that's not working right now, but if we are in 565 mode, it should be uint 16, yeah. So every entry here, we have width, we have height. We usually iterate first for each line, and then for each pixel on that line, you type. Thank you. Thank you. Okay, much better. Much better. Okay, so now we have, yeah, it is really a frame buffer. We can do whatever we want with. That's perfect. Nice, beautiful. So I guess it's time to grab some data. So we need to compile our PIO. So how did we do that again? We look at the code here and we take this, but we need to change it slightly. This time we're going to use the PIO1 because I believe PIO0 is used by the DVI stuff. And then we need a name of the program. It's not going to be called cart. I think it's going to be called N64. And then we need to change a bunch of stuff here. So here, N64 in it. And we want, yeah, how many was it again? So 7, 8, 9. And then we don't need that. We are not gonna mess with the pin directions, so we don't have to mess with that. Not mess with that. We don't even need set pins. Just need the input pins, and that, yeah. So basically, 0 until 0. No. We don't want out pins. We don't even need the jump pin. Maybe we want that later. And there we go. And then the only thing the code does, a cart start, maybe it should be called 64 start. Right. Yeah, it just very simply just reads stuff so that we get some interesting data. It will look like something is happening. I'm just gonna turn on the N64. Okay, so now we got that. Can we build this? No. So I need to include some file. Okay. Okay, it builds, it links. So now we should consume data. Not data, but not here. Then. Okay, here we go. So how did we do that? Yeah, we did the whole this one. So just very simply, yeah, let's just data 120 swap it, just get it, and then we put it in our frame buffer. So it's very simply and this is just for testing that something is happening. So the output of this will be that we see that we can actually sample pins. And it would look something will happen on the screen. So let's see what's happening on the screen. Not much. So I guess I need to power cycle it then. So let's just remove this for now. And see if... Okay, so, okay. It doesn't... Okay, so it seems that I break the DVI stuff once I start doing this. I guess it's enough to do like that. Now it's dead. No, something happened. Okay, okay, it works. Let's try again then. Or maybe I get zeros all the time. That could be it. So I have the N64 up and running, and it's running Mario demo screen. So there should be stuff on the IOs. So maybe I forgot to do something about the whole IO initialization. Actually, let's just update half of the screen so that we can see that are we writing black to all of it? Okay, we are writing black to the whole screen. Okay, so that is what's going on. So is this... Are we doing something strange here? Okay, we should get the clock here as well. Let's do something else. Let's take... let's look at some specific bit. And if that bit is set, we get a white pixel. Otherwise, we get a black pixel. Okay. So let's start with the clock, and the clock should be bit 9, right? Bit 6, 7, 8. Okay, it should be bit 8. Okay. I mean, there's so little going on here, so I don't really see what's wrong in this part. Here I'm reading 9 bits. That might be bad. Let's just read 16 bits at a time. Otherwise, we're gonna get that everything shifts around, I guess. So now I want to have like white pixels scattered, but it's not. So this is kind of strange. So do we need to do anything else? Am I missing something? We have the PIO here. We're not doing anything else with PIO. We do the GPIO stuff here, sure. The LED. That should be fine. Am I missing something here? Let's just read it line by line. We take the PO1 instead of PO0, right? We add it N64 program, which comes from the header file, which comes from this one, which is this one, which is this one. In pins, read pin 0 up to GPIO 0 up to GPIO 15. And that, yeah, maybe that will conflict with the other PIO stuff. Okay, let's just read 8 bits then, and let's just look at 1 bit. If we reverse this logic, now we should get the white upper part, which we do. Okay, which we do. Okay. So at least we are writing stuff to the frame buffer. Yeah. Do we need to do anything more with the GPIO in it? Yeah, I think maybe we do. Because in this code we do this. So let's do that here as well. So let's do that here. Do that. This is extremely weird to me. We should be able to get... I mean, the fact that we are overwriting half of the screen means that this doesn't block forever. We are actually getting data, but the data is always... Let's do something even simpler. If data is set to something, let's just make a white pixel. Now reverse logic. Back. All right. Okay, look at this. This is interesting though. So we're reading 8 bits, and if any bit is set, then we do a white pixel. So maybe that is the sync bit, to be honest. And the sync bit is this one. Yeah, the 8th bit. Okay, let's just go one bit at a time. Just iterate. Okay, so that means that it's some of the upper bits that are set. Right? Because if this... Yeah, I think it's time for UART debugging. But I still don't get it. So we have definitely some bit. Oh, right. So let's do something smarter. Like so. And then does this make sense? So we get 32 bits. Yeah, look at this. We're definitely getting something. So this is Super Mario. There you go. It's done. Ish. So I don't really understand. I do it like this. Okay. Okay. So it was, I see. I guess, okay. So just going back and understanding what I did and why it was wrong. So I believe when I do in pins 8 and push, I will get like a value where the bits are located here. And I was looking at these bits. Now I can write the whole screen, by the way. Yeah, that's a good point. Yeah, but that makes sense. So maybe we should think a little bit. So I guess it's the big endian issue or a bit order issue. So yeah, it depends on the shift direction config. Oh, shift to right is the default. Okay. So, okay, I guess I can read this in the documentation, but essentially we got this value and I was looking at these bits, I guess. So that was because I did the if data is something, I got some data over here, I guess. Okay. Okay, so how do we want to do this? We should wait for the clock to go high. How do we do that? Let's open up the documentation again. Because I already forgot parts of the instruction set. PIO. Wait. Yes, wait. Wait is the cool one. So we want to do wait for upper edge, like rising edge. And I mean, we could use, yeah, pins, because then you can map it differently. Yeah. And we want the pin to be number 9. So just, yeah, we can put some comments here. So 0 to 7 is, or 0 to 6 is papa. 7 is desync. 8 is clock. Yeah. So wait for using clock. When that happens, we should latch data. And I guess I'm thinking of what the smartest scheme is here. Like the thing I did in the FPGA thing, like you can see here, I was like feeding data all the time, but I set the LSB to become 0 depending on logic, depending on this logic. And looking at multiple bits, yeah, right. And this is also a register. So if the sync is 0, then we update these registers. Yeah, the PIO, I'm not really sure. Maybe we can use the X and Y variables to do something similar. So how do we, what is a good way to do this? So after the clock is rising, we could input to X, I guess. What's it called again? Oh, damn it. Oh, no, not in. I was thinking move, I guess. Yeah. So you could probably get away with doing the actual H-sync, V-sync detection in software. Just handling clock and desync in PIO. Yeah, okay. So, oh, I get it now. So we could actually do something extremely simple. Wouldn't this be enough? Or actually like so, I guess. No, this is stupid. Like this. Just like this. And maybe have auto push so that it pushes. Yeah, exactly. Like if we just think about it, we're waiting for the rising clock and we're reading the data and desync, and that's it, right? And then we do the rest in software, because based on the LSB, it's either desync or not. I think if you just find desync once, you can then pack groups of 4 fields in the ISR forever, and then 1 PIO FIFO record per pixel. Nice and easy for software. Okay, let me try to understand. So the way I it's always a group of 4. So we get desync, and then we get these values, and then RGB, and then desync, RGB. So I guess we should just align the FIFO. Yeah, that's probably what you mean. So the OSR is always having this shape. And then we don't even need the desync, but we could pack desync in bit number 7 anyway. But we could make sure that it's the right order. Yeah. So how do we do that then? Wait for pin once, then loop. Oh, you mean that I'm actually... So, okay. So we are... Right, we're actually not waiting for a rising edge. We're waiting for a high clock. So, right. So first we do wait for not desync. So wait for a low pin 7, and then we're waiting for the clock to be high. It might be high at this time, it might not, but at least now we are sure. And then we read 4 times 8, and this will be sync. This will be R. This will be G. This will be B. Am I right? Does it make sense? And then it loops, and we wait for the next desync, because no, we need to do this, and then we can optimize this to loop it. But for now, because I'm a noob, let's just do like this, because right, we have to wait for a low as well. wait for a low. Yeah, wait for a low clock. Yeah, okay, but then I guess we want to loop 4 times, but yeah, for now, let's just do the copy-paste solution and optimize later. And then, so if we just read this code again, we were waiting for low desync, and we're ensuring the clock is high. And only then, we are reading 8 bits into the shift register. All right, we need to end with a push. Otherwise, the data is not being sent. Okay, then watch and just keep stuffing data on the clock forever. Yeah, this okay. So the keep stuffing data on the clock forever. I'm not sure if that is a good idea. It might. I'm not sure about this, but it might be that it could reset at some point so that we're losing sync. Like you can change resolution, and when that happens, this I think gets mumbled up. But I think this is like ugly code, which is good enough probably. So let's just play with this and see if it works. Okay, what do we do here then? We're waiting for data. Data will be actually, will this will be in BGR sync, so to say. Yeah, resolution is dynamic. Yeah. So now we need to do some color conversion. Yeah, and actually you can have the kind of custom resolutions as well. The video generator is kind of quite fancy. Yeah, there are a bunch of registers you can poke at. Okay, so should we? Because we need to know like which row we are at and which column we are at, right? So we need to like find the start, or like is let's just start with just blasting the colors onto the screen, and it might actually look decent, like we might recognize some stuff. So what do we want to do with this? We need to do do you have some nice macro for 565 from RGB? Because I know I can write it myself, but I'm just looking for like building a 565 from stuff. Some define, but okay, well, let's write it ourselves then. Can actually put that here. This makes sense. Okay, something is wrong. Weight 8 pins 7. Okay, so how did weight work again? Weight 1 GPIO. Okay. Let's just go for GPIO then. Oh, thank you. So why does this work and this doesn't? Oh, it's the 0 it doesn't like. Okay, so how did that work again? So weight, polarity, 1 or 0? Weight, polarity, GPIO, GPIO num. Okay. I think what am I doing wrong here? Syntax around. Where is it pin instead of pins? Or yeah, it's pin. Okay. So let's do like this. Okay, here we go. Oh, thanks. Okay, we have stuff on the screen. It's I'm not really sure what it is. It feels like it's the wrong colors. Let's look at the sync stuff. But yeah, it's changing colors. But it looks like the colors are very strong, and it feels like it's wrong. But yeah, let's do the sync stuff. So I guess, oh, okay, so that was when the screen was black, probably. So we're getting there. Yeah, and also I should go for the whole screen. Yeah, there we go. So yeah, I'm just gonna turn it off because you might be annoyed. But is that a Mario? Isn't that like a Mario? I think I see Mario there. I don't know. Okay, so we need to reset. Oh, yeah. So when we get I totally forgot how this works. Because I wrote some horrible C code here where we look for a sync bit. So this is basically we're waiting for a desync is low. And when that happens, we just blast. All right, because this is the first bit, and the first bit was HSync. So that, yeah, that is actually the easiest thing we can do. So yeah, let's do column. So we do row times now the right frame width. There we go. Plus column plus, yes. And reset column when, so if this one has the bit 1 set, if we compare here, we want, no, right, we want the HSync, which is actually the second bit. Okay, so the second bit, if the second bit is set, that means HSync is high, so column equals 0. And then we can do the same thing for the vsync, which is a third bit. So just to make it easy to read, so the, yeah, bit 3, so the fourth bit, yeah. So there we go. And then here we say row equals 0. And then we also do if, I guess, the sync bit or something. I'm not really sure what they should be. When do we want to paint, so to say? We want those 3 to be high. So this, no, this, and this. So basically, no, other way around. There we go. Only then we should paint the frame buffer. And there we go. So now nothing happens, because we need to increment everything. So here we do actually column plus plus, but it's just do that here. Then we need to do row plus plus somewhere. I guess that is when the hsync is going high. Yep. So let's do int sync r, and we do thank you. This is why chat is good. It's really, thank you. So very, very good feedback. Okay, so we're storing the previous hsync, and if the previous hsync was high, which means that we were painting the horizontal line, and this is okay. If hsync was low, but it became high, that is when we reset it. But if it was, okay, we can do an else if to make this even more clear. So just to explain a little bit. So for each word we get, we store the previous hsync. Actually, let's store the whole thing, and it will be even more clear. So int do2 like so, because then it will be super clear. So for each iteration, we store the previous color or the previous word, right? So if the previous word, if it was low and it became high, so on a rising edge, so think right, then we do this, else we do wait a minute, yeah, right. So on the rising edge, we're resetting it. Otherwise, we're Otherwise, if it's only true, like if it is staying true, that is when we do the colon plus plus. Yeah. Yeah, this I think is right. And then we need to do the same thing with the row. So, and the vsync was on bit 3. Or bit 4. So 0 indexed. Anyway, I think, and then instead of column, we should do row. We do row, and there's no bounce checking here because why do we want to do that? I guess yeah, let's skip the bounce check and just run. Okay, this is boring. We shouldn't do that. So maybe this is wrong. So let's skip this and just always paint. Okay. Am I doing something stupid here? Is the bit order wrong? Is it actually? Wait a minute. Isn't it sRGB now that I think about it? Yeah, it is. It is. So yeah, it's an unfortunate name, but we know that S here means sync. And that means that the bits we are looking at should be 30, I think. And we can call it bit hsync. Yes. So this is the first bit we shift in, and then this one, then this one, and then this one. So C-sync, H-sync, clamp, V-sync. Yeah. And we want this one. No, what am I doing? There we go. And then V-sync on this one. Okay, now it's even nice code. Does this make sense? Let's try. And now the colors are on. It doesn't matter because it doesn't work. Okay, so something is iffy with this. So is my logic wrong? So first I extract the bit and then I knot it, right? So if the bit was 0 and the bit became 1 or true, yeah, it became set. So I think this logic makes sense. Is this incorrect? If sRGB, I think that makes sense. So is it, am I thinking upside down with the bytes perhaps? So let's do like so. Oh shit, should be parentheses. Okay. Am I missing something here? We have the row. We don't even use the count anymore. We have the row, we have the column. And then we have the old value. Is the macro wrong? We extract the... Yeah, so this is just masking out... All right, this is actually not correct. This is not correct, but it should actually, I mean, it should just turn it. Well, actually, now that I look at it, so, so the bug is not here, even if the bug there is a bug in this macro, it's not correct. But it doesn't matter. The problem is that we're not updating these for some reason. So let's just solve this first. You'd see something exactly. So I'm just thinking, doesn't this make sense? So I'm thinking like something is wrong with this, with these positions. So looking at the FPGA code again, like what did we do? When have you turned? God damn it! Are you kidding me? Thank you very much for that suggestion. Yeah, you're a hero. I mean, yeah, I feel very stupid, but it is how it is. So yeah, there is something going on. I'm not sure if it's the right thing though. It feels very wrong though. So the resolution is 320 by 240, and it looks like we're writing only a couple of pixels. And it feels like the position. Oh yeah. Oh damn it. Okay, do you get what? So I'm guessing we're using sync, like color values as sync. So maybe the sRGB is actually supposed to be the other way around after all. So let's play around with some different. Let's do like this instead. Yeah, it's really pretty. I mean, it's something. It's basically done, right? Just push it and make a product. Okay, but should we try to use our brain, our collective brains? So I missed a bit. Are you still shifting to right in the PIO program, or did you change that? Yes, I'm not. I didn't change anything, and my brain. Oh, there it's crashed. I guess I overwrote some memory because I don't have any bounce check. Well, I guess we could do like if row is greater than width. Row equals. Same with the column. It should be height here. If you're shifting to right, then the data is going to end up left justified. Yeah, okay. Okay. So how do I do that? I'm sure it's in the documentation. You said something about that a little bit further up. Shift to right is the default. So this one. Okay. So oh, thank you. Oof, auto push. Nice. So shift right and push threshold. Okay. Actually, so shift right. True to shift ISR to the right. False to shift it to the left. So I guess we want it to the right. So that when we're done, the first bit that we shifted becomes bit 0. And that means that we will get BGRS again. Yeah. And that also means that the sync is in this position. Yeah. Because the very first bit we shift in is this one. And if we shift to the right, then we're... Yeah. Oops. Or is it config? Or enter to the configuration. Oh, okay. So it should be in the PIO. It should be here somewhere. Okay. Didn't explode at least. Oh, right. I should have the C here. Damn it. Should we look at this code again? Am I doing something wrong? We're waiting for a low desync, which should be on pin 7. Just double confirming that. We have 0 up to 6, and then 7, and then 8. All right. GPIO 8 is the clock. We're waiting for it to become high. Wait a minute. Just wait for it to have a pos edge, or just that it is high. Logic analyzer time? The thing is, I kind of don't want to this time, because I've already logic analyzed this when I did the FPGA stuff, so I think we should be able to not have to do that. I'm pretty sure I didn't wire it incorrectly. So we have blue, purple. I think it's only the offset. So GPIO uses an absolute offset. So GPIO 8 is always 8. But if you do wait pin, it depends on your offset. So if you have a 7 here, then 0 becomes 7 and 1 becomes 8 and so on, I believe. So it really doesn't, it shouldn't matter here. I just had some issue when I did. All right, because I wrote pins, I guess. I should, let's change that just to make it consistent, but it shouldn't make any difference. I think it's in the C code, yeah. So let's read it together. So yeah, let's ignore this because it's not doing the right thing. So this is, does this make sense? If you have a shift register and we shift to the right, so this is 0, and then so we have like 0, 1, 2, right? This means shift to the right, and then this is the LSB. So when we and this with and 1. So we're extracting that bit, right? And we want the H sync, and we do 1, shift it to the left with 1 position, so that becomes 2. We do the AND stuff. Is there some parentheses error here? I take this one, I AND it with this value, and then I do the not on this, and then I check the actual value with the same shift. This should be POS-edge, right? If we look at the FPGA code again, so the sync bits, yeah. So we're only painting if all of these are true. I mean, I would expect there to be way more crap on the frame buffer, but we only seem to write in sort of a triangle for some reason. So could it, no, I mean, we should find the 0 row by looking at the vsync. What about ditching sync for a time and just filling frame buffer column by column? Okay. How do you want to do that? So with all the color values we're getting. Okay. So you mean we just so I mean, it will be really jumbled up if we just can you explain a little bit more how you want to do this? Like temporarily comment out all the checks and just show pixels in frame buffer. So you want to do the counter plus plus more or less, like so, and then yeah, I mean we need to convert it to 565 somehow. Then we can do the for a second. Yeah. I mean, that's essentially what we're doing here. We just, because we don't have any sync stuff. Or column by column. Okay, so we still want to use the row. Okay. We want to keep the row, but ignore the column, the H sync. I suppose. So like so. You get some kind of diagonal pattern. And if we instead do just count plus plus and just ignore syncs completely. Yeah, right, because we need to do problem is in your frame buffer filling cycle. Here it kind of you can definitely say that there is, if we sync this up, it will probably look a little bit better. I'm just gonna do, I just want to make the screen black, so so you don't freak out from the blinking. I was thinking something. Let's fix the macro. So first of all, we should shift this one to the right. Oh, I really hate this kind of bit shifting. If you just think a little bit. So we want to make 565, so we have 5, 6, 5, right? And we have the 8-bit value. We need to shift that to the right first, with how many? 3 steps, right? And then I guess there's stuff leaking through. So, I mean, I guess we can ditch the macro completely. I guess that will be easier. So let's just do that. We do, for the red color, we shift it to the right. Instead of 8 positions, we need to shift it 11 positions, right? And then we AND it with OX1F. And then we want the green one, which is 16, but 2 extra bits, so 18. And this one is 24, but 3 bits extra, so 27. Yeah, I think this should be right. We've made it into a diagonal gradient. Right. Okay, this looks different. It feels like blue is very dominant for some reason. All right. I mean, if we because we set this to true now, the bit order should be correct. You didn't shift the parts into place. Thank you. So this one needs to be shifted left with 5 plus 6, right? So 11. And then this shifts left to 5. And then this is not shifted, right? Okay, now it looks more like noise. At least we get all the colors. I'm just gonna reset the N64. That was interesting. It's very white. It shouldn't be white. It should be more black. Just look at the frame. What even is this? Here you can see, like, I don't know. Because now we're just doing count plus plus. So we're painting everything, but we should only be looking at the colors. And I guess the white areas, the very white, that might be when the sync is high. So we can actually do this again, right? Which we wanted to do from the beginning. So something like this. So if the sync part is 1 1 1 0, Does that actually make sense? Let's go here. So we have 1 1 1 0. Or no, actually it's 1 1 1 0. So vsync, clamp page sync, and no csync. And that is when we shift those. Let's try this. See if we get anything. Oh. So, maybe I should do like this instead. That we only look at these specific bits. What if we do this then? I think. Actually, this is kind of interesting. So all right. Need to do like this. Okay, am I really stupid or something? Okay, so now nothing happens. I broke it. Oh, because the N64 is not on. Stupid. There we go. Do you need if... Right, so I was... Okay, so I'm kind of elaborating with the active... So the idea is that this condition is the same condition that I used in the FPGA code. So I'm looking at these specific sync bits, and if all of them are high, only then I shift in pixel data. So I believe this might actually be a stepping stone in the right direction. So let's do this. Do like that. Yeah. Yeah, when it comes to brackets and stuff, I really put parentheses around the bit stuff because it's so easy to mess up. Once you start shifting and anding and stuff, it's so easy to mess it up. Yeah. Okay, so the sync stuff is still broken. Yeah. Yeah, you're right. But still like to do it because it's very clear what's going on. Okay, how about catching some frame buffer data and looking at it with a hex editor? That is a good point. So let's connect UART. So it's configured to use the default UART, I think. Yeah. And I've forgotten what those pins are. Oh, it crashed. It didn't crash. Oh, okay, I guess it became black. We go to Pico. Okay, so pin 0 and 1. Hey, that's no good. Maybe that is interfering. It shouldn't really, but or it might actually. Now that I think about it. So let's pick better pins. Let's use the one that we're using here in our project. Like so. And then these ones. Let's connect some stuff. 28. Okay, so I've connected the UART. So let's just look at that. Did we have some print? Yeah, we have some print. So let's just see if we get our prints. Yeah, we do. We do. So we have a UART at least. So should we just, how do we want to do this? I mean, we can just print this as hex, I guess. And see if it makes sense, I guess. So I just disconnected the thing. So here we got some data. I can make it bigger. We get some junk on the UART for some reason. Oh, okay, maybe it's because I'm just gonna connect one extra ground. There we go. Okay, I think you need to the parentheses in the last if. Oh, did I forget something? Thanks for the follow. Which sorry is. Can you say which line number? Because I'm a little bit broken in my head. Which line? Is it this one? Or here? Oh. 172. Okay, yeah. Okay. Okay, we get way fewer hits. So thank you. That was a really good. Okay. Thanks. I'm sorry for not processing your comment properly, because I thought I had like too many parentheses. But yeah, I totally missed that one here. Because usually I'm really careful about parentheses and like make sure that everything is in its own group. But yeah, I missed this one. But yeah, okay, so now we can turn off the printing because that's obviously limiting the speed. Okay, we have a different frame rate and it feels like a little bit slower. So it might be a good sign. Okay, something is still broken. Am I thinking incorrectly with these bits? Should we check if these are 0 then? Like we invert the logic. No. And if we use our brains properly, let's say we only want the H-sync and V-sync then, and that should be bit, so 0, 1, and 3. So bit 1 and 3. 1 and 3. So we ignore the clamp pin, the clamp bit, which we don't really understand what it does, but okay, it's very white and very triangular. If we do like that instead. Do we see any pattern? The colors look like very, very white. But I mean, we've confirmed that we're setting this true thing here, right? So shift right and auto push. Maybe, oh, we shouldn't use that. I mean, we want to do that later, but that might actually fuck up everything, because then we might push twice. Okay, no big difference. I mean, when Mario boots, it's supposed to be quite dark. I think I see a little Mario there, but maybe that's just wishful thinking. I don't know about you, but I think, I mean, you cannot see the hat and the face, right? But why is it so bright? Is it this shifty stuff that's wrong? If we think again. Okay, so let's so we do, well, okay, let's do like that. What do we do? What do we get when we do this? That actually looks same. That actually looks correct. That is also correct. That is also correct. So I think that this, yeah, right. Wait a minute. Should do like that. Yeah. So okay, at this point, I'm pretty sure that that this expression is accurate. It's correct. Or yeah. Yeah. I think it looks good. So why is it so bright? It's almost as if something is wrong here. So are we doing anything strange here? So should we turn these around perhaps? We wait for a high clock and then we wait for desync, but that can be asynchronous. I don't think this will work better. No. We're only seeing the, oh, sorry, thank you. I keep forgetting. There we go. Right, yeah, that doesn't make sense. Oh, thanks for the follow. Okay, so this looks completely different. So in this case, I'm waiting for a high clock, and then I'm waiting for a low desync. And when that happens, maybe I should wait for a high clock again. I think this, I don't know, it doesn't look very good. If I turn off the N64, we look at the camera. This is supposed to be black, but it's not black. Like everything is wrong. Could it be that the 565 stuff is like the RGB 565 is supposed to be the other way around? Like little endian, big endian thing. We can actually test that. So just as an example, we do 1F. So this is supposed to become a full red color over the full frame buffer. And it becomes blue. Okay, so the colors are all shifted. RGB, no, actually I'm wrong. This is correct, of course. So this is supposed to be red. And then this is supposed to be super green. Little endian. Oh, I think actually we everything is in little endian, so it's the value is what it should be. So I think it's actually correct now. So yeah, so this is supposed to be blue. It's this component, and the green component and the red component. So I think everything is actually fine in that regard. So the problem is more the content of our colors. So assuming this is correct, this whole set out shift, where we use false as that parameter, that is the auto push. Shift right is true. Just to have something to test with, let's just shift the other way around. It looks very different. That kind of looks like a blanking area. But now the sync stuff. Now all of the bits should be reversed. But it's still kind of white. Everything is white. White means that the bits are set. So are we doing something wrong here? We're waiting for a high clock. Waiting for a low desync. Hi, Linus. Looks like there's diagonals in your data. Wrong buffer size. So we are kind of debugging the what's it called? We have written logic to detect when the horizontal sync and vertical sync change state, and we have a counter that counts based on that. But the problem is when we start using that, it looks even worse. Thanks for the follow. And I have to turn on the N64. Yeah, and we get this fancy pattern instead. So that obviously means that our sync signals are all messed up. But pizza, yeah. I was thinking of keeping streaming for a while, but I mean, I don't know. To be honest, maybe we hit a bad. I don't know. Can we solve this? I mean, one thing we could do is, of course, connecting the logic analyzer and looking at the data, which I can do. That way we can sort of confirm what we're seeing and if stuff makes sense. Yeah. But I don't know. And regarding pizza, yeah. Your trusty ring buffer capturing 1 frame of data. That is true. Yeah. Where did we put that? Yes. Can do. Yes. This became a little bit overcomplicated. You get a really good. I hit my display with a rock effect going on at least. Yeah, that's true. That's true. Yeah, let's add this back here, I guess. This is a little bit overcomplicated. Let's just make it from scratch. And let's do a few entries. But what did we want to do with the ring buffer? Capturing 1 frame of data. I mean, we can actually just wait for the sync and print. Aha, right, because the printing will, right, yeah. Let's do that. Like this. I've already proposed to display it in a museum of modern art. Just need to come up with a fancy name. Yeah, that time when I hit my head on the display. So this is, let's just simplify this a lot. Maybe not the first, but 5 seconds of rings plus 1. Yeah, I mean, we should start printing when we think we get the sync. let me just make it build first. Ah, right. And this one. Okay, we get stuff at least. That's something. I forgot the new lines, of course. But okay, so maybe we should start printing. Should we start printing if I don't know. So yeah, this should work, I think. Oh, that counter looks weird. So I messed up the counter somehow. Just don't printf on every byte. No. Oh, I mean, it doesn't really matter. Could always do like this. All right, so this is the very first stuff we get. But yeah, because the N64 is running and this, like, everything is already being set up. And it should be black. We get 80. 80 means that the MSB is set. The MSB, wait, this is F. Where is this F? F means that we have 4 bits set. So all of these are 1. And then we have the MSB. It's almost like the All right. Because if we look at the pinout, yeah, this is actually being connected to pin like bit 7. So the MSB of every byte. The MSB of every byte is the desync. So when that is 1, that means that the desync is this pin is high. So we are in this state. So that is actually black color. Oh, wait a second. Now I know why everything is white. Oh my god, I'm so stupid. Because we should shift this with 1 less position. Because the MSB, this is not 8, this is 7-bit colors. So we should shift this to the right with 1 let's see here. Yeah, with 1 extra position. So like so. Now it shouldn't be that white. Let me just comment out this whole that thing. Oh no, not that. What am I doing? This. Yeah, because my mistake was I was treating it as 8-bit colors, but it's not. Okay, we're definitely getting different colors now. It's not that white anymore. Okay, it's pretty white actually. I'm gonna reset. So I kind of don't really like. I'm resetting again. If we just look at this up close, we have a lot of noise. That is weird. And I'm 100% sure that I connected ground. So it shouldn't really be a noisy signal. Now Mario's face is gonna show up now. Yeah, we're looking at Mario right now. And then he's gonna snooze. So this is snoozing Mario. I guess that dark area is like the porch area between frames. So what do we do with that? There was we definitely fixed one bug, and that was this shifty stuff, because we're not using, this is not 8-bit colors, this is 7-bit colors, because the 8-bit is always high. So yeah, good thing we looked at the hex values. Still, it's a really noisy signal, even if we look at this. Like if we don't look at this and let's continue, let's try again. So turning on. This is completely unsynced, and this should be black, but it's really not. Okay. What can we learn from this? Why do we see green pixels? Green pixels is this middle section. This middle section. So for some reason there is some green component in the porch area, which it really shouldn't. Why black is 80? Because because the MSB is this signal. This is 0, 1, 2, 3, 4, 5, 6, 7. So whenever we have valid colors, the desync pin is high, so we always get a OX80 masked with the actual value. So whenever we have color values, yeah, we should definitely the desync will be high. Otherwise, it's one of these. So essentially, rad. I just ordered up 5 light PCBs. Can't wait for them to come. Oh, nice. I mean, the thing is, just keep in mind that I haven't even gotten one. They might blow up your N64. Just, you know, keep that in mind. Just be careful. But if it works, yep, that's gonna be really cool. Yeah, so anyway, the MSB will always be set because of the protocol, more or less. But that also sort of confirms, because we see that pattern, that confirms that our synchronization logic in, let's see here, in the PIO code works. So because we do this, desync, I mean, we're sort of expecting desync to become high during the next clock cycle here. Let's just go through this code one more time. So, or eat your cat. Yeah, no warranty whatsoever. No, it is really. Oh, okay. Nice. Yeah, but yeah, keep in mind this is really bleeding edge. Yeah, it might work. It might work. Okay, so we're waiting for a high clock. We're waiting for desync to go low. And we're waiting for a high clock again. So let's go to the wait documentation and just understand 100% how that works. Wait, because I mean, we could actually add some delay cycles. But I don't really think we need to. Wait for one. Yeah. So do we account for desync OX80 in code? Masking it. No. Or, I mean, sort of. I mean, the latest change I did here was that I shifted it right one more. Oh, wait. Wait, didn't I misunderstand this? So when it's 8-bit, it looks like this. So we should shift it one less, of course. And we have to turn on the N64 as well. Oh, look at this. It's black-ish. And it's Mario. Oh my god, we are close. We are close. Okay, now the sync stuff is broken. But we definitely had Mario there. We definitely had Mario there. Let's put Mario on the big screen. And the autofocus is broken again. Come on, autofocus. Be nice to us. It focuses like 1 centimeter. But yeah, you can definitely see the stride is off, but we are, yeah, exactly. Yep, I also see Mario in my dreams sometimes. No, but seriously, we are super close now. We are super close. We just need to get the sync stuff right. So let's add this if again. Yes. Let's try again. Turn on the N64. Oh, Who is that? That is the Mario logo. Yes, it looks janky, but that was the Mario logo. That is definitely the Mario logo. And yeah, who's that? Who's that? I mean, he's kind of drunk, but you know, getting there. This is Mario on LSD. It's the special edition. But yeah, we definitely have some, we're missing stuff. So could it be this extra, like if we comment this one out, or maybe we're waiting too much. I picked up some Picos for the Swiss boot thing for the GameCube and just saw your post on Twitter about the light version and it's amazing. Oh, nice you think so. I really hope, yeah, we're trying to build a community around it and it's really nice to see so much, you know, buzz around it and it's really cool to see so many people engaged. Okay, so we definitely need this. Could we skip this one then? All right, I'm not showing my code, but I think the screen is more fun to look at. Okay, so this broke it as well. Maybe I was thinking correctly from the beginning. So yeah, I can put up the code again. So I've already said it on the previous stream. Main challenge for me is not to end up with an N64 myself. Yeah, I mean, N64 is kind of nice. You know you want it. But now it's all messed up. Or oh right, because I had the N64 running for so long time, so it was actually entering the demo scene. That's why we didn't get the beautiful face. But yeah, I mean it's Mario on LSD. It's Mario on LSD. So why? Thanks for the follow. Oh, Furan, nice. Nice to have you here. So yeah, I don't know how long you've been on the stream, but yeah, we implemented some very basic PIO code that waits for a high clock, looks for a low desync signal, and then ensures that the clock is still high, and then we thanks for the follow, Story. And then yeah, we just sort of read 8 bits of data, which is 7 bits of color data plus 1 bit of sync data. Okay, so let's look at this code really slowly and see if we made some mistake. So we wait for a high clock. When clock is high, that means that we're allowed to. You know what? We should wait for a low clock. So we're getting the POS edge. So now, so we are running at 5 times. Oh, I should hydrate, but my drink is empty. Okay, so the clock, we wait for a low clock, we wait for a high clock. This means that at this point, we should latch data. And we latch data by waiting for desync to become low, but this already is sort of not good. We should instead have a loop. So I'm gonna write some pseudocode here. So instead of doing this, because this will be sort of janky, like what happens if you end up here when we are in R or G state? Then this is gonna happen when clock is in an undetermined state. So let's do instead like this. If not desync, or rather, if desync, go to this one, wrap target. I guess we want a different label. Let's call that wait for desync n. So how do you do this again? Now we have to write this fancy jump stuff, which we have some code for, because Luke helped us out last time, or a couple of times ago. So first of all, we need to set up the jump target. So my idea is that we want to configure async, and the desync pin is 7. Yes. And then for the actual jump, we do this fancy jump pin card start. Exactly. Just do exactly the same thing. So just to explain what this does, we wait for a low clock, then we wait for a high clock. This means that at this very point, we are at the POS edge clock. And then we have this jump pin, which means if this pin is high, then we jump to this label. So it will loop here a bunch of times until, pop, okay, now it's time. Then we have the, so when we get at this point, let's think here a little bit. I don't know. We still need to do the latching of data. We don't want it to go low. No, we want it to go low. Right. So when we end up here, so let's just add a comment. Async is 0 at this point. And then we don't need to wait for a high clock because we are at the state of a POS edge. So let's not do that. And then we do this. We wait for a low clock, wait for a high clock, read, low clock, high clock, read, low clock, high clock, read, low clock, and then push, and then wait for low clock. Which we actually don't have to do here. So we don't have to wait for the low clock because that will happen here. So let's try this. Oh, you're supposed to latch on neg. Oh. Why didn't I think about that? Did I think about that here? I don't know. It's possible I inverted the clock or something. Okay, I don't know. We can at least we can switch it. But yeah, you're right. The dots look like you're supposed to latch. Yeah, but this looks actually more clean. Like, sure, the lines are horizontal and stuff, but it's not a drunk Mario. It looks kind of worse than before. Are the colors at least correct? I don't know. Okay, but let's invert the clocks then that we. If we do like this, and then we mix that. So one more time. Wait for a high, wait for a low. We loop until it becomes 0. Just gonna double check the jump instruction. The default was this one, right? Jump pin. Oh. the branch is taken if it is high, right? I haven't gotten to play with PIO yet. Looks really useful. Yeah, it really is. And I wish I knew more how it works, because I keep having to look up everything. But I'll get there eventually. Okay, this looks actually more colorful. And the black is really black. Okay, this looks way more stable. Like if we just make the camera big. Gonna run it again. So first we get the Nintendo logo or something. There's some logo in the beginning. I don't remember. And then we get the big Mario head. Yeah, it was kind of grainy before. Yeah, exactly. I thought a lot about that, and I thought, are my signals noisy for some reason? But this looks clean, just wrong. So yeah, oh, of course, because okay, moment of truth. Moment of truth. Okay, yeah. Never mind. Never mind. Looks kind of broken. So previously we had this just count ++, so we don't do any framing, any column, rows stuff. But at least we know the colors are correct. So now we know we should fix our logic. Something is wrong here in this logic then. I just run a bit on an N64. Blaming you, Conrad. Well, congratulations. You're in for a treat. And the homebrew scene is thriving. There's a lot of stuff going on. That's really cool, though. And of course, I will send you a board if you want later on when I get them. It's gonna be interesting. Okay, so is this logic inverted, perhaps? Am I thinking incorrectly? So yeah, the N64 seems to be at a nice level of pretty capable hardware, but still very hackable. Yeah, definitely. Thanks for the follow. Hey, I just came across your project. Awesome work. Thanks. So right now we're trying to implement the video capture using a Raspberry Pi Pico. And yeah, just to show what we got right now. So we've implemented framing, but it doesn't seem to work. But it seems that we get the correct colors. So what you're looking at now is, I'm just going to restart the N64. This is when the N64 starts Mario. So this is like the boot up logo. And then it becomes black. And then you get the big Mario head that is bobbing around. And if you just look at the colors, it really looks like Mario colors. So we're really close now. So we just need to figure out the framing. So these signals, you can see my screen, yeah. So these signals that we're looking at here are the various sync signals, and we're only drawing pixels when these signals are in these states. And as we can see on the frame buffer, there's actually mostly like valid pixels. Like if I remove this, then we're gonna get like the whole porch area and stuff. We can have a look at that. So I think we're gonna see a lot more black now. Yeah. As you can see, we have like this whole black area around the pixels that are interesting to look at. So I'm gonna let it run a little bit longer. Just 1 second. So if we make this big now, you can sort of see that the line width, like you can sort of see the error in width, like the stride. By the way, Conrad, do you have an expansion pack? No, I don't. I guess I should get one. because it would be cool to boot Linux, which you can. And there's even mainline support. Yeah, I'm not kidding. It would be really cool to boot Linux. I'm gonna try that. But you need the extra RAM. Okay, so going back to the code. So that means that this active check definitely works. And that also means that these positions should be correct. Yeah, so we can just remove those. So am I doing some stupid C code thing that is wrong? So we want to check the H sync and we want to check the V sync. So 1 shifted left by 1 becomes a 2. So we're checking the bit 1. So 1 step to the left. And if the old one was false and the new one is set, then we reset the column. Otherwise, so maybe this else if is not good. I meant for testing bigger resolution modes in actual games, but Linux is cool too. Yeah, I mean, you can do a lot of cool stuff, and I think there's some game that needs it. I guess. I mean, it was a thing you had to buy for some games. I guess it would be cool to have that. Maybe I should just make else here. Or maybe I should check vsync is on. Right. Right. Let's rewrite this logic. So if vsync is on and we have the posage. So vsync and posage hsync. Does that make more sense? Is it possible the code is just not keeping up with the incoming pixels? How fast are those pixels coming out? We can... it's 50 megahertz. And I believe it's always going. I think. I don't remember now. So I believe that the clock is always going at the same speed, and then sort of set the resolution based on the port area, like how many black pixels you have with the hsync and vsync not set. I believe. But it's a good point. It might be that this logic is too convoluted now, and that this color conversion is too difficult to make. So maybe we can, as a test, just let's just clean up this code a little bit. Let's remove that, and I guess we could do some smart stuff here, so we don't have to calculate this every time. I guess we can do stuff like row pos. Like this. It's a weird variable name, but I don't know what to call it. But we don't need to do the multiplication each time. We need to do that. And the column, yeah, we can, wait a minute. Maybe we can remove the bound checks. Okay. more likely to be all the branchy logic that is slowing you down. Okay. Time to write the branchless code, I suppose. Oh, now it got really dark. The N64 is on, but we don't see any pixels. I broke it. So it shouldn't really be the bounce check, right? That should be fine. Or is it that it never updates? I guess I need to parse it now. Okay. It's being a bit weird now. I'm gonna press Ctrl Z a few times. Remove this. Put that back. Okay, we're back. And if we go back to the count, anything relying on that count equals 0. So right now the count is, we're just using count. Count is never reset. Well, we had this. Oh, oops. 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 Thank you. Okay, so now we're back again. So at least we're back and it's not broken. Okay, so let's think a little bit. This branch we can actually put all the way up here, I guess. Yeah. So essentially we check, we only want the active pixels. If we don't have active pixels, but actually that is not good either, because if we do that, then we're not gonna catch the transitions, I think. Yeah, because then that is gonna be true all the time. Yeah, so that's not a good solution either. Okay, but if we just go through the code, is there anything we do that we shouldn't be doing? So here we check vsync is true and posage. And then we reset the column. Is that actually kill the ifs or the truths? Okay. This is really cool. Have to run, but thanks for streaming. Oh, thanks for dropping by. Okay, so how do you mean a truth table from diagram? You mean not really sure how to write this in C, to be honest. I mean in a fast way without branches. Actual states. Okay. So let's write it from scratch then. So what kind of state do we want? first we have some sort of invalid state. And then we go into the vsync detected. And then we go into hsync detected. And then we go into async going low. And then we go to vsync being low. And then ideally we should go up here again. And we should get rows. We should get correct rows, but we don't really know when the whole frame is being reset. I believe when that was what was confusing me, because I think with this FPGA code I couldn't get the start of the frame correctly. That was always a little bit of an iffy thing. But yeah, it could be like the order of the hsync and vsync. So I guess we could log this. We should get like, yeah, that we could log this actually. So let's just do F0 on the rendering, because we know we can print pixels and we know we get sort of the correct colors. And then we can use our fancy printed thing, the ring buff. And oh, sorry. So yeah, let's create the enum. What do you? Visual Studio Code is nice, but I don't know how to mark in a window for some reason. I mean, I guess the idea is that vsync. No, okay. So logic analyzer time, but I think I cleaned up all of those captures. I can check here actually in the Glasgow repository. I think I might actually have removed those logs. Like I had a bunch of those, but they were huge, like gigabytes. So I think I cleaned that up. Yeah. So So what makes us go into a vsync? Okay, it doesn't actually be a switch. We need to understand the transitions. Yeah. Okay. So maybe we can just do like actually like So something like this. And then when we print it, we only need to print okay. Am I doing something really stupid here? Oh, right. I need to mask out. Yeah, thanks, Tifmo. And also welcome. Nice to have you here. Okay, here we go. Okay. Oh, what happened with the counter here? I believe we have a bug. Let's just fix that. Okay. Array size times that counter. Right. There we go. And I guess we can actually... Is there a printf for binary? I don't think there is, right? I guess we can do something like this. And then just do... Does this make sense? So we get the bits of the various sync signals written out. Okay, here we go. So this is the funky signal. Oh, wait a minute. It's the other way around, right? Yeah. So from left to right, we have yeah, and the CS, HS, CL, BS. So this is the horizontal, and that is the vertical. Yeah. So the vertical seems to be on more or less all the time, even after 800 entries. So maybe vsync stays on during the whole frame. And then in the between frames, it goes low. But actually, wait a minute. It says here exclamation mark VS. So doesn't that mean that when it's 1, it's actually not set? So this pattern looks kind of odd. 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0. Okay, let me do a different test. Let's disconnect the Pico and run the N64 for a while so that we have, you know, all the resolution stuff has been set up and we are showing the Mario face. So that should be more or less now. So I'm plugging in the USB. And then we print for a while. And actually, let me increase the buffer and change this to a byte instead. And change this to a byte and do this. We can make this 128K entries. That way the print will not. Okay, it's too big, but let's say it's 16K entries. All right. And then, I mean, if we just look at it, it's kind of looks like it's following a pattern where you have these three. I don't know. It's kind of hard to know if we are missing data or not, to be honest. Yeah, here we have the pattern really. Maybe we can. I don't know. Let's see if we can find when it 1, 2, 4, 8. Let's only put stuff here if the vsync is 0. Because we haven't really seen those. Okay, that never happens. That makes me worried. That feels strange. So what? Okay, so explain this. I'm gonna head home for that pizza now. Send a ping if you want a team. Otherwise, later. All right, Linus. To be honest, I'm gonna skip pizza today, but yeah, see you next time. Did you assign sync? Yes. Do that here. Oh, here we go. Now the vsync is 0. It feels like we're annoyingly close, but I also feel like we're not really getting anywhere. And now it feels like this signal, it doesn't make any sense. Okay, turning on the N64 now. Oop. And we don't get any prints. So the vsync bit is like always 1. And I keep it going for a while, and it's still on. The N64 is still on. And yeah, I don't get it. Nothing happens. No. All right, because we're waiting for it to fill up to 16K. Right. So essentially, what this is all of the porch area. And this one, what was the third one? The third one was the CL, right? So yeah, let's have a look at the CL. So let's lower this again. 16K is a lot. 16K is a lot. So let's just do 1K instead. Okay, that makes more sense. But essentially, we're seeing that the CL seems to always be high. Yeah, it's always high. Let's have a look at the CL pin then. CL. So we're looking at this one instead. So does the CL ever become 0? And I am pretty sure it does. Yeah. But when it does, the other ones are always 1. Okay, so this is an interesting observation. So when CL becomes 0, so again, we're looking at this one. So when CL becomes 0, the other sync signals are always 1. And I believe this is happening between frames. How do we actually want to visualize this? Like I could put everything no. Yes, I guess so. Okay, so if we just do some math. If we have 640 by 240, that actually fits in RAM-ish. But because we have the frame buffer and stuff, let's disable the frame buffer. Then we disable the frame buffer. Actually, we're just gonna do some. Yeah, let's just see if this compiles. Oh shit. Yeah, it still compiles. We don't want to do this. Don't want to do that. But we're okay with like rendering crap. So now we're rendering junk data. But that should be fine. Essentially, what I'm trying to do right now is to make sure that that we have enough RAM to fill with all of the state changes. But I'm not really sure what to do with that data. Like, how do you even visualize that? Let's do something else. Let's also print the number of iterations that we have stayed in the same state. Okay, now we're actually getting somewhere. So what we're printing right now, just to explain, is the various bits of the sync bits, the number of iterations that we spent in this state. So here we can see the resolution is probably like 640, but it's actually 664. So we have a couple of extra pixels on the width. So now JTH, if you're there, I think this is starting to become interesting. So here we see that this is the state that we are in when we are getting horizontal pixels, which means that hsync is 0, which actually makes sense because here it actually says exclamation mark. So let's rewrite our logic. So let's do a couple of things. Let's put an if 0 here and write else here. And also just give me 1 minute. I just need to refill my drink. Okay, I'm back. So let's see here. Yeah, so now we're gonna print stuff again, but let's be smarter. So here we could see that this is the way the sync signals should look like. So we want to catch this transition. So we actually want to go from we don't care about, but we actually want the vsync signal to be high. Yes. And then we also want this one to be high. So we actually want to be like this, and then like this. So vsync is high and neg edge on hsync. And then else doesn't, that is no good. We should change that to an else if. And here we should write yeah. This is a little bit unreadable code, but maybe call the actual bits derived from BGRS, not vsync, not hsync. Yep, you're right. It's just yeah. So okay, now that is fixed. So making it bigger. So so if we find this interesting state transition from this to this, I mean, we could even hardcode this. We could even hardcode this. It's a little bit unreadable, of course, but oh. Wait, the bits are in the wrong order now. So it should be like this, because this is proper order and this is a stupid order. I don't know why I printed it in this order, but this is reverse bit order. This is bit 0, whereas this is bit 0. So sorry about that, but this how it is. Yeah, let's just comment that out. And yeah. So then what happens when a line when a line is done. So we probably have like 640 by 480-ish. So every 480-ish, we should get like a deviation from this pattern. So let's see if we can spot it. This looks sus. Right? Here we have something special going on. 0, 0, 1, 0. 0, 0. So this one, the 0, 0, 1, 0. Notice 64, 65, 67. Ooh, that, yeah, I don't know why it is like that. That doesn't feel good. Sorry. But yeah, this looks like the actual new line signal. And actually here we have 325. This is odd. Maybe I should just go down a bit and see if we can find the 0010 pattern. 0010. You know what? We should be real careful with hard coding and monitor actual state changes. Okay. Yeah, this is weird that we have these different. This feels like we are losing bits or something. It's really close, and here's 30 and here's 31. It feels like it's like a little bit wobbly. It's wobbling around a little bit. Oh, you know what? Or actually, I was thinking if those, you know, the 2-stage flip-flop chain, if that is like disabled for some reason on this build, because we were running the DVI stuff. Because it's 5.04, not clean 5.0. Yeah, but I want to think that that shouldn't matter, because if you think about it, we are running 5 times or 6 times or 4 times faster. We still latch on the rising edge. So that only means that we're gonna spend 1 or 2 extra clock cycles in the wait state, waiting for the pin to go high, right? TFMO says, with the clock being 50 MHz, PIO has to be tight timing-wise. No? Could it be missing some data? The input synchronizers are enabled by default. Okay. Yeah. So we should be good. But it's... yeah, this looks odd. If you do a wait followed by an in, then the input sample is exactly 1 cycle after the pin was seen high. Okay. So just looking at our PIO code again. Could this be bad? I mean, we lose 1 clock cycle here, but we do the in, which is just delayed by 1 extra cycle here. So that should be fine. Do the wait, in. Wait, in. Or seen low. Yeah, exactly. So, I mean, that should be okay. We could try to underclock, and like if we don't care about the graphic stuff, and just look at this log instead. So let's where do we have the speed? Here, right. So let's just, for now, set the frequency to, I don't know what, 200 kilohertz instead. Now this looks completely different. But yeah, it looks completely different. Let me try again. Let's turn on the N64, keep it running for a while. And then we're gonna, yeah, turn on the Pico. Yeah, I don't get this. This looks completely broken. Very sorry to ask, but I can't seem to find the MOSFET as a P channel. Only N channel is. No, N channel is, it's the opposite. So you cannot just use a N channel. But there are many different MOSFETs you can use instead of the BSS 80. What was it? 82, 86? Like, yeah, there's a bunch of different MOSFETs you can use instead of that. It's just the one we chose is sort of a very, very common one. But you could also skip it and sort of hook it up in a way so that you only power it in one way, like for debugging. Just be careful with how you connect it. Yeah, exactly. Yeah, this I don't really understand. If I don't set the frequency at all, then we're running at 133 megahertz. Now it looks good. Okay, so it seems when we ran at 200 megahertz, something weird happened. Maybe it's like a PLL thing. But now these pixels seem totally wrong. Oh, I can't seem to find it here in Germany. That's also, well, so it's a power source switch. Like it switches between using the power from USB or the power from the N64. And I guess we can have a look at the schematic because it's interesting topic. This one. So essentially, if you just remove this, boop, you don't place anything here, then let's think a little bit. Then you can only power it through USB, because then VBus, VBus goes to the 5 volt input of the stamp. And the stamp generates the 3.3 volt out, and the Nintendo 64 VCC is just not connected. So if you don't place this, then you always have to have the USB cable connected, even when it's connected to the N64. I think. Yeah, its purpose is to separate power from USB and power from N64. Yeah, but if we just look at the schematic, if you remove this, then this net, how do you select nets again? backtick. Yeah, that is only connected to the cartridge and this, so it's completely disconnected from everything else. So I think it should be safe. If you don't place this, then you have to connect the USB cable at all times. Yeah, should be fine. But yeah, you always have to have the USB cable. But you could also do the opposite and say, okay, I don't have this placed, but I always want to have it connected to my N64. Yeah, then you can create a bodge wire between these two nets. But then it's really, really dangerous to connect it to USB. So don't do that. Because then you get, you're feeding 3.3 volt from your Raspberry, from the module to the net, or the other way around. So it's gonna blow either in the N64 or on the module. So yeah, don't do that. Okay, so this looks really bad. Now we have like completely different values here. You could put a switch there, but you really have to make sure that it's in the right position when you do whatever you want to do, so you don't forget it in the other way around. First time I saw this, how come it's connecting N64 VCC to 3.3 volt out instead of VBAT in? Yeah, so actually the module, I talked with Arthur about this, and we came to this conclusion because looking at the stamps, so this is the schematic of the stamp, and let's see here. This is the IOS of the stamp. So you have the VBAT, but the VBAT is sort of unfortunate because it's connected to this battery charger. So if you have 5 volt connected, it will start charging the VBAT net. So if you have this connected to the N64, it's gonna smoke. Yeah. So, and the 3.3 volt is supposed to be an output, like this net is supposed to be an output from the module, but it's connected in a way that, yes, you're feeding this V out on this voltage regulator, but it should be fine. Yeah, because there's nothing on this side. The enable will not be pulled high. So yeah, because both of these nets will be low when it's powered through the N64. Makes sense. Looks a bit odd at first glance. Yeah, I agree. And it's a little bit unfortunate that it is this way. I really wanted to use the VBAT, but because of the charger, we cannot really do that. So what I did here is I disabled the changing the clock speed. So now we're running at 133, and now suddenly we get these odd 207, 205. So here we're definitely missing pixels here, because we're running at 2 point something x the speed, and we need twice the speed, because even if the clock is 50 megahertz, we need to detect the high and low, which cost 1 clock cycle each at least. So this is actually getting a little bit interesting. So could it be that we need to optimize our PIO code? Could you do like, instead of side set, side wait, you do in pins and then like wait for a clock? That would be cool. So let's look at the documentation again. You can do in delay side set. Yeah, but we want sort of the opposite of a delay. We want to do 2 things at the same time, which is not possible. Yeah. So I guess this thing becomes a problem then, because one clock cycle is apparently quite expensive, since 50 megahertz requires at least 100 megahertz to do both edges, and we're running at 200 something, and okay. Yeah, I don't know. I'm kind of out of ideas now, and I think I need to sleep on this. Yeah, I think I need to sleep on this, and it's getting late, so I'm gonna close the stream now, which ends on a sort of sad note. We didn't crack the nut here, but we got close. So I think, yeah, I'm gonna wrap it up now and say goodbye to you all, and thanks a lot for joining. So we learned a lot of stuff, and it looks like the timing stuff is more hard than it seemed. 50 megahertz is not that easy after all, even if we overclock. We got to see LSD Mario at least. Yeah, that is true. That was actually quite fun. And that sort of proves that we were missing stuff, right? Like the squiggly Mario proves that we're getting, losing pixels. So that's kind of interesting. So does that mean that we need to overclock even more? So yeah, cliffhanger. We're gonna see where we get with this next time. So I think we've proven that this could be done. This might be possible. DVI code requires clock sys to be bit clock. Right, so if we increase the resolution a bit, I think you had like an example at 720p, right? Something really, really high. Yeah. So I got derailed because stuff. Let's see here, this one. So if we like select a little bit higher one, then we get like this one is 400 kilohertz. That's perfect. That is 8 times higher. Then we have like a lot of stuff. You won't be able to get a frame buffer at high resolution. Yeah, you're right. And we need to scale it and all of that crap. Really won't be possible. That's 252 megahertz. So yeah. So yeah, I guess we're close. And it needs more work. But I guess this just proves that this problem was a little bit harder than we expected, and we still don't have a working state machine. Yeah. It's a bunch of stuff, but we can still see, this pattern. Things are not like, once this pattern is perfect, spot on, correct every time, then we can solve the rest of the issues. So I think we need to start in that end. Get clean data. Once we have clean data, we can present the data correctly. That I think so, at least. So yeah, thanks everyone for joining. It's been fun. I've learned a lot, like always. Yeah, PIO is magic, but it's yeah, we obviously still need to do some thinking. Yeah, until next time. So yeah, see you around. Thanks for joining.